Hi, everybody. Sorry, let me get myself situated. Okay, so we are topic 11. We are now talking about spheres. Spheres. Okay, so spheres are three-dimensional circles, balls. Okay, any size. It could be a bouncy ball. It could be a giant structure that's like shaped like a sphere that's a building, the globe, planet Earth, right? I mean, there's just so many different shapes. But the two things we're going to talk about are volume. So these little solids are great because I can just, fill it with water, right? If I fill this with water, how much water would fill it? That would be my volume of a sphere. Okay. Surface area. Along the surface of this, I would want to maybe paint it or wrap it in wrapping paper. So I want to know the area of this circle. Okay? Surface area of the sphere. So here, let's first start about, let's label all the parts so that we know. All right. Up top, all the way down. It can go in any direction, across, diagonal, but from one corner of my sphere to the opposite corner, a line drawn through the middle, that is called my diameter. Then, let's zoom in. Then, any line from the sphere's edge to the very, very center of the circle. Let me do this. This is cool. Okay. Any line from the edge to this right here, the tip of my pen is the center of the circle. That would be the the radius. Put that back on. Okay. The center, we just talked about that. Point right in the middle. The Earth's core is the center of the sphere. Then, this dotted line, if it were a flat plane, it would like cut my sphere into two hemispheres. That is called the Great Circle. Okay, so a sphere is a solid in which each point is equidistant from the center point. So at any direction, no matter which direction I go, towards me, to the side, to the back, those are all equidistant. Those are radius that we just drew those little lines. And then the great circle would slice the sphere into two hemispheres. Here, my friends, is a hemisphere. Okay? Half of my sphere, half of my globe. Okay? So, let's first do volume of a sphere. So here's my sphere. And I can make it sit by taking out the little tab. Okay, so here's my sphere. If I want to find the volume, the formula is as follows. 4/3 pi r cubed. Okay, so what's going to happen is I'm going to, let's just start with number one. Okay, the volume is 4/3 pi r cubed. Because it's, since it's pi radius squared for a two-dimensional flat circle, the cubed we add because it's three-dimensional, pi r cubed. Okay? And if you can imagine a flat plane cutting through, and then that flat plane just rotating in all directions and filling up the circle. I don't know if that even makes sense in your brain, but that also adds to the three-dimensional. Okay? The radius is 7. I'll just put it next to the 7. Okay, so here we go. I'm going to first multiply the 4 times the r cubed because I'm going to divide by 3 at the very end. So I'm going to write that. We're going to divide by 3 at the end. So you're going to need a calculator. Get a calculator. 4 times 7 squared. And the pi we'll just put at the end, okay? I'll put 2 answers. Let's go one step at a time, right? 4 times 7 cubed pi divided by 3. That's really what we're doing. That's the simplified way of this math problem. 7 times 7 times 7. Oh, here we go. I'm looking for it on my calculator. Is 343. 343 is 7 cubed. So 343 times 4 is 1,372 pi divided by 3. So really and truly, I do need the full answer. So I'm going to use on my calculator 1372. I'm going to do the pi button. Don't just do 3.14 because that won't get you the exact precise decimal answer. Actually use the pi button. So I'm going to do 1,372 times shift pi equals. So 4,310. Then I still have to divide by 3. Here we go. The volume is 1,436, round to the nearest hundredth, 0.76, what is it? Inches cubed. Okay? So these formulas you need to have memorized. Okay, so that's the volume of a sphere. Let's now talk about the surface area of a sphere. The surface area, I'm going to jump down, as you can see in your notes, I'm jumping down to number 4. I literally could not do every single question in notes. There's 11 questions. You guys, this video would be like 30 minutes long and you would just die. You'd hate it. It would be awful. So surface area of a sphere means that I'm going to wrap it in wrapping paper or I'm going to paint it, and I need to know how much that is. So here we go. I've got this formula. 4 pi r squared. Remember my great circle? My great circle slices this in half. So I need to find the area of the great circle, which is the flat plane that cuts through, right? So the area of this flat plane that would cut through, this flat surface right here, right? And then I'm multiplying it by 4, okay? So that means that this flat circle, if I wrapped 4 of them around, it would cover my sphere. So here we go, surface area. It is 4 pi r. Oh, the diameter is 24. What's my radius? Half. Radius equals 12. 12 squared. Okay? So then it's really 4 times 12 squared, 144 pi. Okay. 144 times 4. 576 times pi. Put pi in first. Pi. Oh, I lost it. 144 times 4. 576. 576 times pi. Pi times 576. 1,809.56 millimeters cubed. I'm sorry. Only volume is cubed. Anything with the word area in it is squared. Okay? And especially since the formula has the squared in it, we know that our answer will have a square in it. If the formula has a cubed in it, the answer will have a cubed in it. That's one trick you can remember. So that's the surface area of a solid sphere. Volume up here, 4/3 pi r cubed. Do the divided by 3 at the end. Surface area, 4 times pi r squared. 4 times the great circle. So that flat circle that cuts it, that flat plane that cuts the circle in the middle, 4 of those would cover my sphere. All right, let's find the volume of a hemisphere. Here's a hemisphere, friends. So here's my hemisphere. And I want to know how much water would fill the inside of this hemisphere, right? Okay, so here we go. The volume formula is 2/3. Well, guys, if a whole sphere is 4/3, a whole sphere is 4/3 times pi r cubed, then a hemisphere is half of 4, 2 of the thirds pi r cubed. And for the hemisphere, I know it seems likely that shouldn't it be if this is 4 pi r squared, shouldn't this be 3 pi r squared? No, because I've got 2 flat planes that would cover the bottom. And then I have this third one here. That's where the 3 comes from. 2 and then 3. So, and it's also a proportion, like half of the circle, but 4 of them fit in, and I have the flat surface here. So it can't be the full 4 pi r squared. It's 3 pi r squared. So, but right now I'm just doing the volume. The backside is surface area. Volume. Okay, here we go. 2, I'm going to remind you that I'm still going to do 2 pi r cubed, and I'm going to divide by 3 at the end. Okay? Divide by 3 at the end. So, here we go. Well, 5 to the third is 125. I can do this in my head, yes. 5 to the third is 125. 125 times 2 is 250. So this is where you're going to get your calculator out. Pi times 250, 785, divided by 3. My volume is 261.799. Guess what we have to do? I don't want to round to the hundreds. I'm just going to put 8. I mean, I could put 80, but nobody does that. So, kilometers cubed. Okay, we good? All right, 3 problems in the front. I'm going to do 3 problems in the back. Let's get moving. We're already at 15 minutes in this video, so here we go. All right, so now I'm going to do the surface area of the hemisphere. The surface area, I'll just write it for you. 3 pi r squared. Sorry. The surface area of a hemisphere is 3 pi r squared. So here we go. We just found the volume, but the surface area. So pi. Radius, what's half of 12.2? Half of 12, half of 0.2, 2/10, 6.1 squared. All right. 6.1 squared is not like, I mean, it's close to 36, but 6.1 times 6.1, 37.21 times 3. So 111.63 pi is so far my surface area. So I'm going to do, my calculator's like backwards. So pi times 111.63. Okay, so it's 350.7 centimeters squared. And again, this 695, the rounding there, I don't want to do, and this becomes a 7, and then that's a 0, but then the 5 keeps it a 0. So anyways. All right, good so far? So I did one of each. If you feel that you need extra practice on that, let me real quick write in the answers in case you want to practice another one. This answer, one, pardon me. Okay, so if you want to copy down those answers, like do it just to see if you can do it. There's those answers. So number 9. Okay, how putting this into real life. Find the volume of a sphere with a great circle area. So the great circle is this flat area, the flat plane. So this great circle area is 201.06 square inches. Well, if I know that this flat area is this 201, the one thing that I can't do any problem, like the volume of a sphere is this. Of a sphere, I'll put a circle in it, is 4/3 pi r cubed, right? Well, the problem is that if I know that this flat circle is 201, I don't know the radius, and I'm going to need the radius to find the volume. So I'm going to know, well, this flat circle right here, this great circle, is just a plain circle. So that formula, the area of this flat is, so I know the area is 201.06 pi. I don't know the radius. So if I don't know the radius to this shape, I can't even do the problem. So since I know a portion of the information, I know the area of this flat circle. Flat circle area is 2-dimensional pi r squared. So I'm going to plug in the area of this great circle, flat circle, and then I'm going to equal it to the formula for area of a circle to find my radius. That means that I'm going to do divide by pi first, I guess, is, yeah. Okay. 201.06 divided by, let me see if I can do this, pi. Divided by pi. 63.999, I mean, come on. Let's just call it 64. Nice. I'm going to not do a crazy problem for you. I'm going to make it easy on you. All right, so then I square root both sides, right? 8. My radius is 8. Now I can find the volume of this sphere because I know that I can plug in an 8 for this r. 4, remember I do the divide by 3 at the last, pi 8 cubed divided by 3. Remember? Divide by 3 at the end. 8 to the third, I don't know. This is just 64 times 8. That's 512 pi divided by 3. Okay. 512 times pi. It works normal that time. 1608.495, guys. That's like 0.5. Guys. Did someone catch this? I hope so. I hope you have like 3 of you are raising your hands in my class right now. I did 8 to the third. It's 512, but I never multiplied it by 4. And this is why you don't use, you know what I have? I have whiteout. Let me get it. Okay. 512 times 4. 2048. Okay. So I'm using pen so you can see it on the video. But the point is that pencil's always best. You should be using pencil right now. And for every math class for the rest of your life, you need a pencil and a good eraser. Pen just makes your work look so messy if you mess up. So, anyways, 2048 times pi. 6,433.98. I mean, come on, that's going to basically 6434 is really what it should be. I can even do that. Divided by 3. Okay. Volume equals 2,144. I'm rounding to the nearest hundredth, guys, hundredth. Then I look at the 0 and I don't touch 66. If I were rounding to the nearest tenth, then I could put 0.7. Okay, do you see that? So I'm just going to keep it 66 and I'm going to say inches cubed. All right, so this took a while because I had to do a two-parter. First, I had to find the radius of the shape. I was given that a flat great circle of my sphere was this. So I used the area formula to find the radius. Radius was 8. Then when I knew that the radius was 8, then I was able to find the volume formula of a sphere with this. Okay, going down to the bottom. So what's going to happen is I have a multiple part question. The Henleys, the farmers, the Henleys, have a silo on their farm to store grain. Assuming the entire space is used, what is the maximum amount of grain that the silo can hold? All right. So I have obviously a cylinder and I have a hemisphere. Okay. So the first thing that I need to do is know that there's the volume of the hemisphere. That is 2/3 pi r squared, right? And then I need to find the cylinder, okay? Cylinder formula volume is, so I went and I got my notes, and these were the notes for cylinder. Pi r squared times height, right? Pi r squared times height, right? So looking back at your notes, if you're given a shape that has two pieces put together, is exactly what you should be doing. Okay? So now I need to find each shape at a time. So I'll do my, I guess I could do my hemisphere first. Hemisphere, cylinder. Okay? So I want to fill this silo with grain and I need the volume inside, right? Okay, so the radius of my hemisphere, okay, the diameter is 22. So half is 11. And luckily, that's also going to be the radius for your cylinder. Nice. So it's just multi-use. So I'm going to use these two formulas, and then I'm going to combine them at the end because it's one piece plus the second piece. Hemisphere. 2, I'll do divide by 3 at the end. Pi 11 cubed divided by 3. And don't ask me why I wrote like the smallest ever in the world. 11 times 11 times 11. 1,331. Oh, times 2. I made that mistake on the last problem. Can't do that again. 2662. 2662 times pi divided by 3. All right. 2662 times pi times shift pi equals 8,362.92. Sorry. Divided by 3. All right. So 2,787.64 is my volume of my hemisphere. Then I have a cylinder. The volume of my cylinder, pi r squared times the height. Okay. Let's talk for a second, guys. I only care about the height of my cylinder, don't I? I don't really care about the height of the bulb on the, dome on top, the hemisphere on top. So here's the deal. The whole cylinder is 45 high. How high is it from my center to my top of my hemisphere? If every direction is my radius, how high is this shape right here? From here to here, how high is that? So I'm hoping that you're noticing that the radius tells from the center to the edge of the circle. So this is 11 high. So if the whole thing is 45, but I only care about this stopping point right here, the top of the cylinder, I only want this section, 45 and take away. Are you thinking 45 minus this radius of the hemisphere? 45 minus 11. That means that the height of the cylinder is 34. 45 minus 11. Okay. All right, excellent. So I'm going to do back to the volume of the cylinder. Volume of a cylinder, pi r squared times height. Pi 11 squared times 34. Right? So, excellent. 11 squared is 121. Use your calculator. 121 times 34 is 4,114 times pi. So I'm going to do it times pi Whoa. It's huge, guys. 12,924.51, yeah. Okay, so now I need to add the volume of both of these shapes. So add the volume of both of these shapes, and that's going to get you the volume of the whole silo. So okay, 12,920. Okay, let's just start at the beginning. 2,787.64 plus 12,924.51. Whew, 15,712. 15. Now it's the volume, and it's all in feet. See, my unit of measure is feet. Feet cubed. Okay, so I hope I went slow enough. So those are my notes, all right? And I'm still at 30 minutes. Ugh, I do apologize. This was a long video. Okay, so now let's talk about your homework. Your homework is this page, which you see, right? So I'm going to then only have you do the circle problems. 2, 3, 5, 7, 9, 12, 13 is the same as number 9, right? And then 16 is a cylinder with 2 hemispheres. Or honestly, guys, these 2 hemispheres make up 1 sphere, right? So be smart. Do the volume of a cylinder plus just, the 2 hemispheres make a sphere, okay? So that's not going to be too difficult. You won't do 14 and you won't do 15, okay? All right. Make sure to write these 2 things down because on the PDF, they haven't been written down yet for number 13 and 16, okay? All right, and I will post these answers up. We're going to do, let's see, the day that you see this is today. Okay, so it's Tuesday. We will do a review of all volume, and then the surface area. The only surface area shape that we did was this cylinder today, but we did do volumes of like the cones and cylinders, and so there's a lot going on. Triangular prisms, all that, rectangular prisms. So we're going to do a big review of all of that tomorrow, Wednesday. All right, I'm going to end this video. It's getting too long. Okay, guys, talk to you soon. Reach out if you need me. I am always here, okay? And you'll see that I've updated your grades. The last quiz that you took remember on Pearson, and then your weekly homework for the first week of May. Okay, bye.